magnetic field, which has a fixed value. What changes is the angle. So I don't have the thing here, but the flux goes from maximum to zero to maximum to zero. It goes through, every time you turn it, it goes through a cycle that will, if we graph the EMF versus time for that, we'll see a sine or a cosine. And so the flux is always changing. The time it isn't changing is if the field is this way, when the coil's here, it's going to be at a maximum flux and not change much. But then it starts changing, and then the flux goes to zero. And then it comes back in the negative sense. So it's continually changing and gives you an output that looks like this. So, we're talking about the motor though. Well, the generator and the motor are the same thing in reverse. So if I spin the coil in a magnetic field, I get a changing flux through the coil, and it induces an EMF that looks like that. But if I put current into the coil in a magnetic field, it gets repelled by the magnetic field, and when it turns, one turn, it should get stuck. Because now, like say, this is a north pole, this is a north pole, it's repelling, and now this is the south pole. So you were supposed to see, if you didn't, that there's a switching mechanism on the motor, that when it gets, it's repelling, it's repelling, it's repelling, now it switches current. Switches the current in the opposite direction, so now this is the north pole, not the south pole, and then it pushes it again. And maybe you saw that or didn't, but there is a switching mechanism there. In order to use it as a motor, you have to have this switching mechanism. To use it as a generator, it doesn't matter, you'll just produce this. However, if you want to produce DC, then you also, like with the motor, you want to reverse it every half turn. So rather than getting this, you'll get this. And that gives you a DC output. So those motors would actually, with the switching mechanism, would produce an output like this. So you don't need to go into great detail, just that in the case of the motor, the thing's going to turn a half turn and get stuck. So you need to have a switching mechanism that switches it every half turn. The question is then, how did that little coil, there was no switching mechanism, and I talked to some of you, but not all of you. The coil had the wire that it set on. And in order for this, if this was a coil of raw copper, and you wound it together, it would all be touching. It would just be one winding. So in order for this to act like 100 windings, the coil, the copper has to have insulation on it in the form of clear varnish. And so otherwise this would just be one mass of copper wound together. So if you looked at the wire, you'd see the shiny varnish, but just on one side, the varnish was scraped away. And so when you set the coil down on that scraped away side, the battery puts current through the coil. There was a little magnet on the top, right? We're running out of time, so I'm not going to go get it. And so that would cause the coil to turn, and it should have turned a half a turn and got stuck. But because it's not stripped on the other side, it turns a half a turn and it shuts off. So it kind of glides through that part, and then it gets, so you're just pushing it every half turn. kind of like a swing. If you wanted to push a swing from both sides, you'd have two people on the swing, right? But it goes one end, it doesn't get pushed.
How come when I put it on, it just kept spinning?
Momentum.
Because it doesn't get, when it gets to the place where it gets stuck, it shuts off. And so it just spins, and every time it comes around, it gets a little kick, just at that point.
Up.
You know, just like if I push a swing here, and then I go to the other side, and I push the swing, I'm gonna stop it.
Yeah.
Right? But if I just push from one side, and I don't push it at the other end,
Like a part of it has something to do with the gravity, right?
no, that's not really an issue here. The thing is pretty well balanced.
Well, I mean, just like the force and the fact that
No,
light,
it's just momentum,
no?
it's just rotational momentum. Once it's spinning, it's gonna keep spinning unless you stop it. And the reason it keeps, you say, but why doesn't it get friction? Well, every time it gets to the point where it's stripped, it gets a little push. And it, you know, that on-off with the contact with the thing, it happens very fast, because the thing would spin, like you said, it would spin very fast. Okay, so I think we'd better start the quiz. If you have more questions, see me out.